All right, here is your quiz review video for your Unit 3 quiz. For these first two, we're finding dy dx. So it's derivative of y with respect to x. So every time you have a y, you're going to chain on the derivative dy dx. So this will be e to the y dy dx minus 7x to the sixth equals 0. Again, anytime you do a derivative of a constant, that's going to be 0. That's all the calculus. Now we're going to do a whole lot of algebra. So we're going to add this 7x to the sixth to the other side. And then we're going to divide by e to the y. So we get 7x to the sixth over e to the y. So same exact thing for this one. It's just a little bit bigger of a problem. We'll have 3y squared dy dx. Oh, there's something on the table here. All right, equals derivative of 5x is 5. Derivative of cosine is negative sine. So the negatives are going to cancel. So we're going to have plus sine of y, and then again, chain on dy dx. So the first thing we're going to have to do is get both terms with a dy dx to the same side. So I'm going to subtract over this sine term here. So it is going to look like this. And then we're going to factor out dy dx. It's a greatest common factor. And then our last step is to divide over everything that is in the parentheses. The biggest thing with these is try not to do a copy error, which actually I'm looking through mine now, trying to make sure I didn't copy anything wrong because they are such a jumbled mess, and it all just looks crazy. So try not to do a copy error. In fact, rewrite as little as possible. All right, this one, a pebble is dropped into a calm pond, causing ripples in concentric circles. So if you dropped, something into water, you know that the ripples are going to be circles that come out like this. Again, these are our related rates. So we're going to do what we just did above, except instead of dy dx, every single variable is going to be with respect to time. So every single variable will get that chain rule, and they'll all be dt. You can draw a circle if you want. This one doesn't really require a picture. Let's get our information. The radius of the outer ripple is increasing, so we're going to have a positive rate, 3 inches per second. So that's our dr dt. Now, because all the circles are moving and everything in related rates problems is moving, you have to pause at one certain moment because you can't talk about all times at the same time. So you have to pause. So it says when the radius is 9 inches. At what rate, so here's our question mark, is the area changing? So dA dt is our question mark. It should be positive because the circles are getting bigger. Now you need a relationship between the variables. They will oftentimes not give you things for circles. They expect you to know them. The area of a circle is pi r squared. And then we're going to take the derivative. So dA dt equals, now pi is a number. So that's a constant. That's going to just sit out front. We're going to bring the 2 down. So it'll be 2 pi r to the first. You can put a little 1 in there if you want. And then chain on dr dt. And then after that, you're just plugging everything in. So it'll be 2 pi. Our radius is 9. Our dr dt is 3. You don't need to multiply all that together. I would just leave it alone. If you make a mistake, it's going to be wrong. We do need units. It's not inches per second, though. For an area, it's going to be square inches per second. Areas are 2-dimensional. Volumes are 3-dimensional. So areas get a squared, volumes get a cubed. All right, a man standing on a dock is pulling in a boat by a rope attached at water level. So this is going to be our right triangle. We did one just like this in the notes. So let's see. This is the water down here. This is going to be the boat. He pulls in the rope at the rate of 35 feet per minute. So I need a variable for that. I'm going to call that X. This is connecting the boat to him. So he's up here on the dock. I can't draw a dock, but he's up here above the water. And this is the rope. So he's pulling it in at a rate of 35 feet per minute. So that's going to be negative because as he pulls in the rope, this distance is shrinking. It's decreasing. So we have a negative rate. The man's hands are 12 feet above water level. That's constant. The dock is not growing or shrinking, and he's not like jumping up and down or anything. So that's a constant 12 feet above water level. How fast? So here's our question mark. Is the boat approaching the dock? So the boat is going this way. And so I'm going to call that dimension y. dy dt is our question mark. That should also be negative. The boat is getting closer to the dock, so this distance is shrinking. And again, we have to pause at a certain moment. It says when the boat is 9 feet away. So that's going to be when y is 9 feet. So our relationship between the variables is our Pythagorean theorem. We're going to have 12 squared plus y squared equals x squared. Derivative, this is a constant, so that's going to be gone. We have 2y dy dt equals 2x dx dt. You can cancel out the 2's if you want to, or they divide out. And then we're going to go and plug everything in. So y is 9, dy dt is the thing that we're trying to find. I don't have x, we'll come back to that. Dx dt is negative 35. So if you are missing something, you go back to the original relationship, so right here, and you plug in what you have, and you try to solve for what you're missing. So this is going to be 12 squared plus 9 squared equals x squared. And I'm just going to work that out. And sometimes you have to do things like this without a calculator. Is that going to be 225 equals x squared? Now that is a perfect square. That's going to give you 15. Here's the other thing that you can do if you know some of your Pythagorean triples. So do you know 3, 4, 5 is one of your triples? We've actually just scaled that. We've multiplied them all by 3. So 3 times 3 is 9. 4 times 3 is 12. Was the other one that we had. So we had 9 and 12, and then 5 times 3 is 15. So we took that 3, 4, 5 triangle and just scaled it. So if you notice that, then you kind of don't have to maybe do all this work, but either way, all right. And then dy dt, we're going to just divide over the 9. Again, please don't do anything with that. It's free response. Just leave it alone. You do need your units. It's feet per minute. And it did come out negative like we were expecting it to.